Hello, good morning everyone. So my name is Shermy Elardis and I am from BAT4B. So my topic now is about acid sulfate soil. So this acid sulfate soil is the very most common problem in aquaculture and in fish pond production. So one of the major problems in site selection for coastal pond farms in the tropics is the prevalence of acid sulfate soils or cut clays. So even though such soils are also found in freshwater swamps, the problem is more pronounced in brackish areas. So one of the major problems that kuno in selection for coastal pond farms or in aquaculture is the prevalence or meaning yung paglaganap or very known na acid sulfate soil or those acid sulfate soils condition or cut clays within such area na mooy konsakan as a fish pond. So even though such soil are also found in freshwater swamps, so the problem is more pronounced in brackish water areas. So this area is the freshwater swamps, and this part is the brackish water areas. So the brackish water areas is the water there is saltier than a fresh water, but not so salty as the seawater. So this also known as an estuary. Okay. So the distribution of acid sulfate soil is worldwide, with the large areas found in tropical deltaic and coastal zones. So in 1979, estimated that at least 60% of the ponds in the Philippines is by acid sulfate soil condition. So therefore, in siya causing siya as a major problem for site selection for the pond farms. So the reason will be discussed kung bakit naging major problem yung acid sulfate soil. So the first reason is that highly acid conditions inhibit the production of fish and fish food organism. So therefore, yung highly acidic condition within that area due to acid sulfate soil condition is it can cause to inhibit or makakause siya ng fish kills or meaning dili siya provide ng survival sa fish and also fish food organism. So elements particularly ang iron and aluminum are released into the water in toxic quantities which render phosphorus unavailable, causing severe phosphorus deficiency for algal growth. So those elements do kuno na iron and aluminum it can cause na mag-lack ang phosphorus availability within that area which makakause siya ng phosphorus deficiency and therefore it cause na wala siya algal growth na motubo ka bali. Wala siya algal growth na mabuo which is as can serve as food for fish. So sudden fish kills during rains after long dry periods are a common phenomenon due to leaching of extremely acidic water from surrounding dikes into ponds built on such soils or acid sulfate soils results from the formation of pyrite, which is fixed and accumulated with the reduction of sulfates from salt water. So muna to kung gingon na. Due to highly acidic condition of the soil, which is mag-spread siya towards that area, so makakos siya ng sudden fish kills. So wala na siya survival for fish. Kaya makakos naman siya ng killing or death of fish. So especially mahitabo siya, mahitabo is during the kuno na rains after the long dry periods. Mag-leach daw kuno dito ang extremely acid water from the surrounding dikes. Dikes meaning is yung mga parang yung borders niya sa ponds. Then mo spread siya, then result siya ng killing for the fish and also the food microorganisms. So this acid sulfate soil is created through the formation of pyrite, which is pyrite is a shiny yellow mineral consisting of iron disulfide and typically occurring as a cubic crystal, so which is accumulated or na-acquire siya through reduction of sulfate from the salt water. So the process involves is bacterial reduction of sulfate to sulfide, partial oxidation of sulfide to elemental sulfur, followed by interaction between ferrous or ferric iron with sulfide and elemental sulfur. So a sufficient supply of sulfate and iron, high concentration of metabolizable organic matter, and sulfate-reducing bacteria such as disulfovibrio, disulfuricans, and disulfomaculatum in an anaerobic environment alternated with limited aeration are the factors that give rise to sulfate soil. So muna na siya ang process na involves ang bacterial reduction of sulfate to sulfide. So with the existence of sulfate reducing bacteria, such as katong akong mga nalitok, it turn niya ang sulfate into sulfide. Or shall we say from sulfate to sulfide. Then, with partial oxidation, meaning with partial oxidation or exposing of sulfide, it turns to as elemental sulfur, and so with the interaction of ferrous or ferric iron with sulfide and elemental sulfur, thus nabuo ang acid sulfate soil. Anyway, the difference between sulfate to sulfide and sulfur is based with their atomic numbers. So what is this acid sulfate soil? So acid sulfate soils are saturated with water, almost oxygen-free, and contain microscopic crystals of iron sulfide minerals, commonly known as pyrite. So oxygen-free meaning dili kayo siya exposed. Di siya exposed permi with an oxygen. So kung if ever na waterlog, so that is why dili siya kayo exposed. Soil containing metal sulfides is usually not a concern when it remains undisturbed or covered by water. But if it is exposed to air, it can pose a risk to water quality. So according to this, soil daw kuno which has contains of metal sulfides already within such area is dili daw kuno siya big deal when it remains undisturbed, if ever na di pa siya na-disturb. But if it is exavide, yung na-dig na siya, dig up or na hilabta na siya and na-disturb na siya, if ever also if it is exposed to air already, so that is why makascause siya og risk towards sa water quality. So when acid sulfate soils are disturbed, they can generate large amounts of sulfuric iron, sulfuric acid, iron, aluminum, and sometimes heavy metals. So that is why nga delikado na siya or makakontribute na siya risk towards sa water quality na based on tana for fish survival, fish growth, and cultivation. But since na naman ang metal sulfides within that area na disturb man, so that is why na makakause siya toxic towards the water quality and also sa survival for fish. So, what exactly the impact of acid sulfate soil? So this time, we're gonna tell the exact impact of acid sulfate soil. So the first one is the agricultural crops. So in agricultural crops, so since when an acid soil, have you noticed na kapag acidic yung area is limited lang yung growth and production of agricultural crops within that certain area. So that is why na gamitan nila of pambalance para mawala tong acidity sa area. So pag acid ang area, of course, pag dagan ang kuan, sumasinay ang growth. Next one is fish and aquatic life in general. So, fish and aquatic life in general, kay pag ang water niya, ang quality sa water is not suitable for the fish and other aquatic life organism. Pag di siya suitable and also toxic siya, like the acid sulfate soil nga, pag-spread niya into the water, so maapektuhan niya ang quality sa water, so that is why na makakrusyal sudden kills. Next one is the engineering, construction, and infrastructure. So what is the main problems and fish ponds in acid sulfate soil? So muna to, insufficient growth of algae, slow growth of fish, and killing fish. How do you identify acid sulfate soil? So, this is how it looks kapag undisturbed acid sulfate soil siya. So, a healthy mangrove forest with a dark blue-gray soil colors common to undisturbed acid sulfate soil. So, in ang color kung undisturbed kibal siya. And later on, matakal na to ang potential acid sulfate soil in the active or the actual. So, yung potential is yung undisturbed pa, and yung actual is they already disturbed. Okay. Next is the disturbed acid sulfate soil. So, this is how it looks kapag yung area is na-disturb na ang mineral sulfide within that area. So, in mangrove swamps area, the most favorable condition for pyrite formation exists in the zone between the mean high water and mean low water level, which have limited periodic erosion due to tidal fluctuation. So, sa mangrove swamp areas daw kuno, like katong undisturbed pa, so the most favorable condition for pyrite formation or pagbuo ng pyrite or mineral pyrites is dito daw kuno dapit sa zone between the mean high water and mean low water. Dito sa within area na common na mahitabo ang fluctuation or tidal fluctuation and limited erosion or katong area nga kung asa siya nga level of water mo high and low. Na somehow ang katong soil na part is night time nga mahanginan siya, ma-aerated siya, then na time na dili. Ferrous iron or Fe2+ is released during atmospheric oxidation of pyrite. So, pyrite is those are the minerals. So, pyrite under moist condition at an optimum moisture content of 30 to 40%. So, ang ferrous iron daw kuno is ma-release lang siya during atmospheric condition is yung ma-expose sa air. And the optimum moisture content of 30 to 40%. So, at low pH, oxidizing bacteria convert ferrous iron to ferric iron. So, in that area na low na ang pH niya is ang oxidizing bacteria daw kuno i-convert niya ang ferrous iron to ferric iron na. So it can remain in solution in appreciable amounts only at pH values in the range 3 to 3.5%. Okay, and is a more effective oxidant for pyrite and elemental sulfur than free oxygen. At higher pH, almost all ferric iron is hydrolyzed and precipitated as ferric hydroxide. So, moto, at higher pH, mo na reason na, kung higher ang pH, mas daghan ang ferric iron na ni hydrolyzed and precipitated as ferric hydroxide. So, basic ferric sulfide is also formed during pyrite formation, oxidation. Elemental sulfur is oxidized to sulfuric acid by the bacteria. So, in selecting sites for pond farms, one has to take into account not only the existence of acid sulfate salts but also the potential for acid condition to develop as a result of drainage after construction. So, therefore, in selection of sites daw kuno for fish ponds, not only na ato i-consider lang taon na nato kung asa tong dapit na sites na naan siya active or actual acid sulfate soil. So we must also consider also the potential acids condition. So that is why dapat kabalo ka saan mo paglantaw na kini siya na area is potential and this area is not only nga makabalo ka nga kani area actual but also the potential. Because if ever na ang imong na-construction is ang potential for acid condition is ma-develop lagi po siya as a result of drainage after construction. So, syempre, ito siyang i-release. So, the levels of pyrite and acid neutralizing components such as calcium carbonate from mineral deposit and metallcation have to be considered. So, those are components na neutralizing components. For example, ang calcium carbonate is helpful siya for quantum mabalance tong area ng acid sulfate. Next is the use of combined criteria as for example. So, muna ang mga basis kabali na para lang tawan nimo, kana siya na area is good for fish pond construction or not. So, number one is the sedimentary relationship and sulfur sources. So, dapat makita gini mo na non-existence of sulfur sources. Kaya para ma-sure nimo nga this area is not really can be existence of acid sulfate. So, landform and vegetation and soil characteristic. So, those are the bases several bases na to consider for aquaculture and fish pond production, construction and production. Okay. This has been suggested as a basic approach or a basic way for recognition and prediction of potential and actual sulfate sources, just at what I have said a while ago. So, although it is desirable to have both field and laboratory investigation, it is considered possible to use certain simple criteria with confidence. So, even though kuno na much desirable or much better nga iagin mo siya field and laboratory investigations. So, kung dili sa mga person na dili yun nila kaya na i-cater na mo undergo pag field and laboratory investigation. So, it is okay na makabalo ka those approaches na stated above para can be a basis or certain simple criteria na makandak nimo para lang make sure nimo na kanang area is capable for site selection. Okay, potential and existing acid sulfate soils are generally found in mangrove swamps and marshy back swamps. So, the very most common, aside those in other part, is ang mangrove gutted swamps and marshy back swamps is the most very common na destination or sites na kung asa makita ang potential and acid sulfate soil or actual acid sulfate soil. So, in the seaward side of radial deltas and marine and estuarine plains, so that is most commonly. Okay. Tidal brackish water vegetation within rotting system is usually related to accumulation of pyrite. So, association with the reed mangrove or rhizopora, nipa, and melaleuca stands is a clear indication of potential acid soil. So, manalay itong mangrove areas, nipa and melaleuca, moto sila ng mga kuan is much better sign na dito ang source of potential acid soil or na dito na area is naay ka ng possibility of acid sulfate soil. So, soils that are likely to become acidic have a high organic matter content such as the fibrous roots of mangroves and a gray subsoil with dark gray to black specks or matters or partially decomposed matter. So, that's the reason na mas prone na potential acid sulfate soil in mangroves areas because dito ang area is high ang organic matter content due to the fibrous roots of mangroves and gray subsoil with dark gray to black specks or matters of partially decomposed matter. So that is the sign to be considered pag nantaw ninyo. Okay, so the detection of actual sulfate soil is easy. So, to detect actual sulfate soil is easy. So, kaina isang potential. So, those are the signs or the basis na pwede nyo makita nga kana siya within this area is can be a potential acid sulfate soil. So, this time is the actual, so existence na of acid sulfate soil. So, the area which has a acid sulfate soil is they can be recognized by the filial matos. So, kaina black specks or mottles of partially decomposed matter, but in actual it has pale yellow mottles of the top of the soil overlying pyritic subsoil. So the older acid sulfate soil shows the red brown. So ang older na is it has a color of red brown ferric hydroxide. So itong mga nakita na ninyo kaya akong ipakita sa picture. Okay, the older acid sulfate soil shows the red brown ferric hydroxide. So their pH is generally below 4 na. So a comparatively easy method of estimating the extent of acid and non-acid soil layer is by implanting sticks coated with red lead paint in the soil profile. So this can be most commonly conducted by soil analyzer person. So by expert. So it can be done by expert. So it will be used by a implanting by sticks coated with red lead paint in the soil profile. So, hydrogen sulfide generated in the layer with active sulfate reduction turns the red lead marking black within about a week, leaving on the stick a record of the upper limit of the present sulfide accumulation. So, hydrogen sulfide, so it can be generated to in the layer with active sulfate reduction, which is na-mature na ang red lead marking black within about a week. So, due to katong gibutangan na to siya, gigamitan na to siya kanang methods and also an equipment, and with the help of an expert person, yes, din na to siya makita mas clearly. So, in many tropical areas, the available sites for pond farms may almost all have such portals and there may be little choice. The available sites for pond farms may almost all have such portals and there may be little choice. So, ano ni, sa atong area ko in many tropical areas, so, mas gamay rin ako ang choices. Kaya mas daghan ang area na ay acid sulfate soil, potential and actual kaysa sa wala. Okay. In such reason, or in such cases, sites that can more readily be reclaimed should be selected. So, yung pwede pa man is can be selected. So, basically, reclaiming consisting of removing the source. So, those areas na can be possible na kanang magamitan pa siya methods or masolusyonan pa siya agad-agad is pwede siya nga boy i-select ni mga site. Eh, syempre, little choices lang sa tropical areas for na best or suitable for fish ponds production. So, that is why yung mas madali pang maagapan is muna lang imong pilihan since mas daghan man ang area na ay acid sulfate soil. So, reclaiming consists of removing the source of acidity, rising the pyrite from the pond bottom and flushing it out of the 10 to 15 cm deep surface soil and preventing further diffusion of acids, aluminum salt, and ferrous salt from the subsoil. So, meaning, a reclaiming process is consists of removing the source of acidity. So, how to remove? So, by oxidizing the pyrite from the pond bottom. So, if oxidize or in-expose siya sa air muna, ang katong pyrite, nagikan siya sa pond bottom din, i-flush it out. So, kuhaon siya. I-flush it out siya for about 10 to 15 cm deep surface soil and preventing further diffusion. So i-remove siya, i-take out siya, then mao ni ang basis sa kanang kalawmon sa soil na i-take out, then preventing further diffusion. So i-prevent na nato ang much more na exposure sa pyrite kung if ever naapas sa ilalong. So, acid and toxic elements are also leached and removed. So, katong mga acid and toxic elements na nagkuha na is also ato po siyang i-remove. Of course, i-remove siya. Okay? Makakos man to siya kanang kuan sa quality sa water. So, if this is feasible, so kung mahimo siya successfully conduct, then the farm can be made suitable for aquaculture within a period ranging from 3 to 5 years. So, kung successfully conduct siya, then the farm, katong area is suitable na to siya for aquaculture within the period na consists of 3 to 5 years, depending on the extent of the problem. So that's all, and thank you.